Hello everyone, it's March 30th. Alright, want to do today's challenge. Alright, the previous 2 days was pretty bad. Uh, the head was not in the right place and then just didn't perform very well. Hopefully today will be different. But today, the interesting thing is I was trying to do the homework of wavelet transform. Man, that thing is interesting, but at the same time also pretty tough. Pretty tough for me to wrap my head around. But the thing that helps me by doing this is I think I finally understand what the convolution neural network is. It's just it's just a I would say like a different way of doing wavelet. I kind of suspect they might have a root in wavelet because in wavelet you have to do convolution, and in order to do the convolution you have to create. It's not a 3 by 3 little matrix, but you have to create a little matrix to do the convolution of the original image. So the convolution idea for the CNN, I think I don't know which one comes first, but to me, I think wavelet comes first. That's early 2000s. So I think wavelet comes first, and then the people uh, in machine learning they saw how wavelet is quite successful, to compress data, and JPEG changes its algorithm to wavelet in the early 2000s. I think they kind of see that and they realize when you use wavelet and you can detect edges, you can extract features, right, automatically, and then they made optimization, or they made changes to it. So the wavelet, you have like different kinds of wavelet, right? But for them, they say, okay, we're gonna make it easier. They just use a 3 by 3, I don't know, 4 by 4, whatever the convolution matrix is. They put it in there, but basically it's the same thing. It's a convolution, right? It's a convolution. You're taking um, you're taking I won't say like average. You're transforming. You're transforming the original data to something else. So yeah, so I'm stuck honestly right now on the wavelet. I was able to do the transform, but I'm stuck to do the reconstruction. I think I have an idea, but I'll do more of that after I finish the challenge. So let's get the challenge done as fast as we can, so we can go back to wavelet. Man, these signal processing techniques are just mind blowing. They're all magic, all magic. All right, let's see this one. Search a 2D matrix. Search a value in a matrix. The value has fallen from integers in each row are sorted from left to right, and the first integer of each row is greater than the last integer of the previous row. Ooh, I seem to remember this one. So each row is sorted, and they say the first integer of each row is greater than the last integer of the previous row. So is that sorted this way? Hold on, let's see. Each row are sorted from left to right, and the first integer of each row, which is the smallest of each row, is greater than the last is the largest. So it's sorted this way. It's and we try to search it. So what do we say? We can do binary search on the first column, right? Binary search on the first column, and if it's landed in between these two, it has to be from this, right? Between these two, so 2 rounds of binary search. Okay, so this one is not too hard, not too hard at all. Maybe I'll do another one today, but well, I have a difficult question that I still haven't touched yet. Man, not today. No, not today. I mean, I probably do. I don't know. Probably do another medium, but then I have to finish homework. The deadline is tomorrow. All right, so we're gonna do binary search, and from bisect import import bisect. I like to use bisect right. Okay. So we need to grab the. No, we don't want to use NumPy. All right, let's not using NumPy. Let's just using directly matrix. So we say column, first column, F column, right? First column equal to for let's say row in matrix, right? For row in matrix and row 0, right? That is the first column, and then we're gonna do binary search. Let me say I don't know, index column index, right? Equal to bisect right F column and the target. Actually, why call F column? Let's call it column. It's fine. So when we say if equal to this, we say if a that's fine. That's fine. We can do binary search. So now we're gonna do row index equals bisect right matrix ci minus 1. Right? We always do minus 1 and target. All right. And then we say if I want to return matrix ci minus 1 and ri minus 1 is equal to target. How about this? How about this? And we just realize we don't need to column because we can put columns here. All right, let's try this. Yeah, this one we can generate test cases. But I think this is right. I think it's the exact same thing, but just switch a different number. So first one is true, second one is false, okay? And then this is matrix and target. This one is search, matrix, and target. Yep, I think this is good. Run it here. And we pass. Let's try this. Oh, wow. Yep. What happened previously? Oh my god. Wow, these are Java. What was the first method I used here? Try to check. I'm actually tempted to go look at the difficult problem. 74. Binary search the first column to obtain the row where target might be in, then binary search that row. O log m plus log n. Ooh. This is OM. So it's OM plus log m plus log n. 59. 59 and 59% ranking. All right, let's take a look. So this, I think, is the original solution I have. Ugh. Yeah, pretty fast, right? Oh, don't tell me I'm using NumPy. Ooh, oh my god, look at this hideous thing. No. You don't have to do it this way. I mean, actually, we can also just say return. I'm not sure. Can NumPy do this? Target in NumPy dot array matrix. I don't know. I'm actually no idea. NumPy is not defined. Wait. I need import NumPy as I thought it's already defining it. I mean, in the past they have NumPy, so I'm not sure if they made change to the whole thing. Yep, you can do that. You can do NumPy. Let's see how fast the NumPy goes. All right, doesn't matter. All right, so we're done. Let's take a look at the difficult question. So this is from last week. Oh my god. All right, I didn't even have time to take a look. Okay, what is this thing? Maximum value of k coins from piles. Let me just refresh this thing and push this one here. Maximum value of k coins from a pile. So I have a pile to get k coins. I want to find the maximum value of it. Is that what it is? Okay, we have n piles of coins on the table. Each pile consists of a positive number of coins of assorted denominations. In one move, you can choose any coin on top of any pile, remove it, and add it to your wallet. Given a list of piles, where piles I is the list of integers denoting the composition of the ith pile from top to bottom, and a positive integer k, return the maximum total value of coins you can have in your wallet if you choose exactly k coins optimally. So I have two piles. We have this, and this. And k is the number of what is k? What is k? A positive number. Oh, they take exactly k coins. So we take two coins, 1 7, 7 8, or 1 100. Okay. Holy moly. 7 coins. 1 2 3 4 5 6 7. 1 2 3 4 5 6. All coins from the last pile. Ooh, this is interesting. How many piles are we talking about? 1,000 piles. Within each pile, I didn't say, but I didn't say how many are within each pile. But that doesn't matter. Oh, very interesting question. So we know the total number we can pick and have so many piles. DP, right? Let's try DP. So how do we do DP on this? We say pick 1, all right? Let's say k equals 1. Well, if k equals 1, then we pick the largest top among all the piles, okay? That reminds me of maybe we can use a priority queue to arrange so we know which one is the largest. But that's 1, right? And it's not right. Actually, this tells you cannot pick the largest on the top, because if you pick the largest on the top, you're gonna get 600 and a 1. But if you do this, you get a 706. So we can, but if k equals 1, definitely. But if k equals 2, right? If k equals 2, k equals 2. Maybe the problem is if you have a large coin down deep into the pile, right? Very down into the pile, then it costs, right? It has costs to get to it. Maybe we can. What is the cost? You shouldn't say the cost. It's like to get there, you'll have to remove. Like if you want to get this, you have to remove this. It costs you 1, right? It costs you 1 coin, 1 chance, and these cost you 0, right? These cost you 0. So maybe what we need, can we do like a priority queue, but with, let's say, multiple, right? Multiple of what? Multiple of the cost. Or we can say the remaining moves, right? What can we say the remaining moves? So like this one, like if we take this, what is the remaining move? So if we take this, remaining moves is 6, and the value is 1. 7 value 1, and these is 100. If we take this, that's not 100, it's 101, right? It's 101, and remaining move is 0, right? 101, remaining move is 0. And this we cannot do, right? Because we only have 2. We can only take 2. So this is how we need to take 3. So in this case, we can say this coin can give us value 1 with remaining 1. And next one is 101 with remaining 0. And here is 7 remaining 1 and 8 remaining 0. So we push all this into priority queue, and the 101 zeros pop out because we say we compare the first one, and we say if the first one is the same, then we compare the second one. So when we say compare the second one, we want a larger, right? So it's going to be a max heap for both, right? A max heap for both. We want the first one to be larger and want the second one to be larger as well. All right, so in this case, what we have in the second example, we have 100, right? And we have 6 remaining, right? So we have 106, 106, blah, blah, blah. And then we coming down to here. So this one we have 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1, and 706, 0. Now we push all of these things to the priority queue, and the 700 come out first. Okay, that's a thought. Let's try this. I'm not 100% sure. Well, I mean, this is a hard question, so I am allowed to try an error. Okay, so here is the think. The thinking part is like this. We need a I don't know, we need a queue, import heap queue. All right, we need a heap queue. And then we're gonna do a heap, right? And then we say for p, for pile in piles, okay? For pile in piles, and then for, I don't know, for coin, let's say I coin in enumerate pile. I remove it from 1. And then we say heap queue dot heap push heap. So what do we push in? What we push in is, I just realized there's an easier way to do this. Let's say from iter-tools import accumulate. Right, we can do accumulate. So we can say this and earnings, right? What's it called? Value. I value in enumerate instead of pile, accumulate. So we do prefix sum on pile and start from 1. And then this one gonna be minus because we're gonna do maximum heap. So minus value and the remaining should be k minus I, right? The remaining k minus I. And of course it needs to be negative, so it's be I minus k, right? I minus k. And we say if I is larger than k, and then we break. We don't have to put those in, those are not possible to put in. So I, because we're counting from 1, right? Otherwise you do this. So blah, 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 when we're done, and now we're gonna pop, right? And then we keep track on how many, so when we pop is how many coins remaining, right? How many coins are remaining. So let's say we pop the first, and then this one tells me how many, let's say we have 3 coins remaining. And the next one, then we need to number of coins remaining. And if we pop the first one and the second one coming up, we say if we do this, we have that number of coins remaining. So we can say k minus this is how many coins we need, right? How many coins we need. So once we do that, if the number of coins we need is not as, yeah, what like, hold on. What if, let's say one pile we take 2, we get a value. The other pile we take 3, we get a value. And then the other pile we take 5, we get a value. And then the 5 value is larger than the 2 and the 3 individually. But if you combine 2 and 3 together, that's bigger than that's definitely possible, right? How do you prevent that? Well, it's a good question. How do we prevent that? Well, what we can do is, I don't know, if the first and the second and the number of coins is smaller than k, then definitely we should take both of them. So we take as many as we can. Take as many as we can. If we take as many as we can, maybe we shall sort this instead of heap. What if we sort it? Okay, that's fine. Let's sort it. Maybe even better. Instead of sorting it, we can put it into a hash map. Right? We can put it into a hash map. Let's say taking 1 coin, right? What are the values? Right? Taking 1 coins, these are the values. Sorted. All right? These are the values. Sorted. Taking 2 coins, these are the values sorted from large to small. 3 coins, 4 coins, all the way to k coins. These are the values sorted. So now the question is, But there's another issue, because if I take, let's say, a large coin, and then some of those will no longer be available because that was already taken. Ooh. Hmm. Let's maybe take 3 coins on the first. I think we go down to this rabbit hole. I don't think that's working. What would DP be like? Well, DP usually you require a state, right? You require a state, and then you try to work around with the state. What type of state can you get from this? Well, the state will be from each pile, how many you have taken from each pile. How many you have taken from each pile. And we have 1,000 piles, okay? If you have 1,000 piles, and how many have taken from each pile? Look at this. Sum of all the piles is smaller than 2,000. So it's not too big, right? It's not too big. So you're gonna do, I don't know, like what? If I know, usually let's say if I know the smallest, okay, not smallest, the largest I can take for 6, like this would be a good example. If I know the smallest for 6, which is 600, by the way, right? So let's say we know that, and we know it's taking these. Does that help to find number 7? Well, under number 7, what we can do is we keep whatever we have in the past, and then we just pick the current largest, right? The current largest. So let's say we have the previous, like the index, right? The index. That's the state. The previous state is 1,000 length 1,000 vector, and in this case, the previous just 1, 1, 1, 1, all ones, right? So that's where the previous are, and now we want to pick the biggest one and the next one, which can be accomplished through, I don't know, it can be accomplished. I mean, they don't have any more, right? They don't have any more, it's just be a negative value, right? We can just do a negative value, or 0, we can do 0. It doesn't matter, okay? So let's say we pick out the largest one, and we say that is one way, right? But there are other ways. What are the other ways? So we say this is the previous biggest, right? If we remove one of them, we say, okay, we don't pick that, right? If I don't pick that, now what else should I pick? If I say, okay, I don't pick this, right? But then you have so many different options, right? You have different combinations. It doesn't work. I don't feel like working. I don't feel like that is working. So from the previous smallest, it's really not. I don't know. Like if we say if we don't pick one, right? If we don't pick one, I need to pick 2. I need to pick 2. And if we don't pick this one, we pick one of the others, right? Or we pick one of the others. And there are so many others to choose from. And then we can pick one of these, we can pick 2 of these, This is hard. If I can iterate through all different possibilities for k, but that will be very, very costly. 1,000 piles. I'd say 1,000 piles and 2,000 coins. There'd be tons and tons of possibilities. There gotta be something out there. If for each pile I compute, do 1, what's the cost? Or what's the earning? To 2, to 3, all of these earnings. Let's say for the first, right? For the first, I can do this for the second. So it's basically a cumulative sum for each row, okay? How would this help us? Well, by doing this, we can say if I, like say, the first one I pick 2, the second one I pick 1, the third one I pick 2, and I can just add them together, right? So now the problem becomes how much of each row you pick, right, in order to get to the largest value. Okay. What if we have only one row, right? Only one row, don't just keep picking, okay, right? So now I add another row. Okay, now I add another row. Now what do we do? And let's say we'll have like a row, like 10 values, and then k is a smaller value. So I pick, for the first row, I just pick whatever the first 5, okay? Now the second row comes in, and basically we just need to reduce some from the first and then give it to the second, right? And we try to make it as big as possible. So we can gradually reduce the first and increase the second. Then we'll find a new equilibrium, and then that's the largest. Now we add a third row. Okay? Okay, we add a third row. Now what? Now the first 2 need to move to accommodate the third. That doesn't feel right. I have no clue. All right. Take a look. Topic. It is DP. Prefix sum. I was on these two general ideas. I was dynamic program. I was thinking about dynamic program and a prefix sum. Okay, so I have prefix sum. Okay, so all I need is to figure out a dynamic programming scheme. But I don't feel I don't feel any dynamic programming in there. So if it's dynamic programming, which means the previous state can be used to compute the next state. Okay, let's think again. So the previous state is this, right? So hold on. What type of states do we have? What if, okay, we have the sum of all, okay? Because previously I have the sum of all of this, and now I just go one by one, and I would look back into that. So that can give me the biggest, okay? So now we have the biggest of this, which also I have one by one, so I can pick 0 of this, or 1 of this, 2 of this, right? 3 of this, and 0 of this. So, and we also get a state, okay? And then the third one comes in. So what I want is all different combinations of the first two, okay? Different combination of the first two. And I want this. I want to know what is this, what is this, what is this, what is this, right? Basically, it's like 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 0, 1, 1, 1, 2, 1, 0, 1, 4, right? So we need all that, okay? We need all that. Basically, is the total number of coins from 0 to k, right? 0 is definitely 0, and then 1 coin. If I want 1 coin from those 2 rows, those 2 piles, what's the biggest? If it's 2 coin, what's the biggest? 3 coin, what's the biggest? 4 coins, what's the biggest? Right? And then the newcomer comes in, you have 0 coin, right? And then which is just the same. The 1 coin, the biggest 2 coins. Yes, yes, this might work. This might actually work. Prefix sum on each row. Let's do this. Let's do this. I think it might work. So what do we say? We say pre-sum s equals list accumulate p for p in piles. Okay. Now what we want to do is create a DP, right? A DP table. Yeah, we create a DP table. Gonna be length. So k. Let's do k plus 1. All right. So take 1, 2, 3, 0, 1, 2, 3. So that's the start. Okay, and then for each row we add row one by one. Right. So for each row, let's say for PS in pre-sums. Right. So for each row, what do? We're gonna say for I in range, let's say range k plus 1. Okay. What we want is if I pick 0, then well, DP0 will never change, right? So like if I pick, hold on. So what I want is if I pick 1, and what is the biggest, right? So we look at previous 1, and then currently if I pick 1, and which one is bigger, then I put it in there. Okay. So, but what about 0? 0 is I don't pick. Right? So if k equals 0, now if I don't pick anything, so I don't have to do 0. What I do is just well, do we need this then? Because you have to pick, right? You have to pick at least one. So why don't we just go k, right? And then we just go k, okay? And then this is like we pick index 0, right? If we do index 0, index 1, index 2, and now it's index 0, then we say dp I, right, shall equal to maximum dpi. This is the previous, which means I don't pick anything of the current row. And now I say I pick one of the current row, which is psi, right? And I'll pick 2, pick 3, pick 4, whatnot. Doesn't matter, right? Doesn't matter. But of course, that is not k, right? Because k can be bigger, k can be smaller, so it should be the minimum of k and length of ps, okay? Length of ps. So we go through this and we pick this, pick this, pick this, right? And then we update dp, update after this. Eventually, we're gonna return maximum dp. All right, let's see if this one works. And these two test cases are pretty good. So I think it can really show us if this method works. I feel like this method works. If it doesn't, I think it's just because I probably didn't understand it completely. Man, if this one worked, that would be awesome. It should be because it's not that complicated. I still remember. I think the first ranked person finished everything like in 10 minutes. Jesus. Just by saying this, I'm just very, very much impressed. Yeah, this is. I think we are right. Honestly, I think. And two coins. That should still be 1. K has a value. Oh, K has to be small. Okay, K 1 coin. And K cannot be. Oh yeah, K can only take 1 coin. Yeah, then it should be 1. Yep. All right, try this. Come on. Oh, not right. I thought we done here. That's fine. All right, let's see. Output 351, expected 494. It's fine. Just take a look. Print pre-sum. 4 row and pre-sum. Print row. All right. So this is what we're dealing with, right? And then that's 9. 1, 2, 3, 4, 5, 6, 7. Okay, hold on. So that's 351. That ain't right. Because I never get to. Oh. Shoot. I see. Oh, wait. Hold on. Let me think. I think we're at the cusp. What happens is the K is larger than the longest. That's the problem, right? K is larger. So if K is larger, we can do 1 round. And this method only allows K to be the same. That cannot be larger than this. So this basically saying if we want to pick 1, 2, 3, 4, 5, 6, 7, I'm going to pick 7, then the largest is 351, right? But now we can pick 2 more. So we should run it one more time, but remove all this, right? Remove all this. And the largest shall be 125. 400, no. It shall be 44 plus 91, right? 44 plus 91, hold on. 44 plus, no, cannot plus 91, I have 2 left. 44 plus, well, no, 51? No, 51 already used. 44 plus 37, that's 81. 351 plus 125, that's 476, that's not 494. How did you get to 494? Well, what about 125 plus 44 plus 325? That's 494. I see. We're getting close, but not right. So we pick 1, right? We pick 2, pick 3, pick 4, pick 5, like all the way to the 5. So we have, if you take a look at the DP table, right? We can also like print the DP table. The last 2 element is empty, right? Yeah, the last 2 element is empty. That is the DP table, which means this is the best way to go. All right, but then if if the k is smaller, then we're done, right? So now the problem is k is larger. So if k is larger, we can say, okay, so that's pick 5, right? So we have 2 left. And another round of search? How do we solve this problem? Because each step is not computing the maximum we can get. Or is it? We are computing the maximum we can get if the k is 5, right? If k is 5, let's just double check, right? Let's say 1, 2, 3, 4, 5. It works for 5 when the k is, I just want to say, I was about to say, but it's not right. Do right, 180, 200. Ooh, we have issue. 4. How? No, I think this is not right. Hold on. So now we pick one. So let's say this is the maximum I can get. I pick 2 from the previous, okay? From the previous, right? From the previous, if I pick 1, I get this value. If I pick 2, I got this value, right? Doesn't matter. Now the new one comes in. If I pick 1, then previously need to pick 4. Pick like -1. Oh, what the hell are you thinking? It's PSI plus DP. My God. DP what? DP. Hold on. Now, what? So if I pick I as a number. So no. So what we want to do is to k, okay? To k, and if it's a 0, right? DP 0, then it's the previous value and a current PS 0 plus there shall be k minus I, right? -1, because it has to be -1. So it's just current, I pick this, and then what the previous one, right? What previous one, I said pick, like if I pick 1 now, and a k is 5, then the previous 4 was the biggest. And we'll have this problem out of range. Okay, so we need to handle this out of range thing. DP is fine, right? The PSI is the issue. PSI is the issue. So what we need to do is, so can I go larger? Oh yeah, I can go large. I need to go, so it is the minimum. So this is still minimum of k, right? And len ps. Wait, this is because double dipping? $622. What the hell did you get this number from? Hold on, it's not right. It's not right. Shouldn't that be? If I take one of this, right, and then and then P is this, my value, plus dp. So the previous, let's say, pick 6. What's the biggest that we can previous pick? No, not 6. Right? K is 7 minus, no, K is 9. 9 minus 0. That's 1, so 8, right? So that's go to 8. Shouldn't that have been minus 2? Yeah, I guess a little bit more reasonable, but still not right. Right, still not right. It should be minus 2 because is it minus 2? Because it should be I minus 1. So K plus 1. Yeah, so K minus I plus 1, right? That's the numbers, and then minus 1. So yeah, it should be K minus 2, but it's still not right. So what happens is I start from here, right? dp 0. So I take 0 here. And then 9 minus 0, 2, 7. Okay, so we pick 7 on here. So what's the biggest? I can pick 7. And plus, 0 to 7, the 7th position, which is 8, and then plus 1 is 9. So that's 37. And now I say, okay, I want to pick 2. Right? I pick 2, then I have 125. And the previous one, so that will be, let's do this. It'll be more fun, right? So that's 37, that makes sense, okay? Now, next round, 51 comes in. 51, and we say, if I do this, I want to know the previous, so large, how much we can get. Well, nothing, 51. And then if I got 115, I say, I want to pick 2, right? So the previous, if I pick 2, the previous need to pick 7. So basically, we're going to go to 6, position 0, 1, 2, 3, 4, 5, 6, which is 0, right? Which is 0. So I say, nah, so it's 120, it's 115, and it doesn't work. And then 180, right? Which is our current pick 3, right? Current, I pick 3. So the previous need to pick 6. So 0, 1, 2, 3, 4, 5. So that's 180. Current 20, this is good. This we have problem. So I have a 1, 2, 3, 4, 5. Current pick 5, right? Current pick 5, which is 292, okay? And the previous, so I say, so 0, 1, 2, 0, 1, 2, 3, 4. So I equals 4. K is 9. 9 minus 4. 9 minus 4. Oh, we know why. Because this one added to this. Dang it. So you're saying we should go from back to the front? Is that what you're saying? Back to the front? But I will never fill up this. Because I can only go 5. Right? Well, to make things easier, okay? To make things easier, what I think we should do is just get a temp. Okay, so that's not DPI, that's temp I equals DP and then this. But now there's one more thing. We shall go to K, right? If it's smaller than we do, if it's larger, If it's larger than the current, what do we do if it's larger than the current? If the length is larger than the current row, that just means take 1, take 2, take 3. So if we take this, and then we can add this, right? And then we take this, we add this. But I never get to 9. So if we get to this, if we get larger, then it's this plus that, right? Plus 4 of the previous. Okay, hold on. So what we're saying is this has to be K, but this PS, this one is the minimum I, and we say len PS minus 1. Okay, so just make sure that we will not, which means if this I gets too big, we just say we take the entire thing and a plus whatever's the other thing, right? So that's we record on the temp, and after that we can say dp equals temp. Still not right. It doesn't matter. We analyze. Let's analyze. And I'm going to put a thing between so I can analyze. All right, let's analyze. So now we have everything filled, right? I have everything filled. So I have 37, 1, 125. So if we want to pick 3, then we just pick 2, right? If k equals 3, then we just this. Okay, so this all makes sense. Now, 51. This does not make sense. Okay? Does not make sense at all. Because I'm at 51, I say I want a 0. Temp a 0. So it's 51, 0, right? And plus, that'd be 51 plus, These shall be 0. These shall be 0. Why don't we, why that is the case? I think that's the case because hold on. So this is the maximum coins we can get, right? Maximum coins we can get. So if we got 37, right, and then previous is 0, and then 125 is 0, and then when k equals 2, right, and then 2 is larger than this, okay, so it's larger than this. Number of number of coins in total, right? If the number of coins in total is smaller, then we cannot do, right? Then we cannot do. So number of coins we have so far. Number of coins we have so far. Number of coins. So we do what, like coin count? Total coin, right? Say start with 0, and then the first PS, let me say total coin plus equal to len PS. Okay, and then this is going to be the minimum of k and total coin. Okay. student. So the work for this, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it should be. So 591. Okay, so what we have? 51 is right. 125 is right. Now we have 3 coins. All right, 3 coins either. So not 3 coins. If I want 3, then on here I need 9, 0, 1, 2, 9 minus 2, 7 minus 5, right? So 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, right? So that's 180, 200, 295, 325. So here, this one is, okay, what is this? This is 1, 2, 3, 4, 5, 6. I have 6, right? I say, okay, I want 6 coins. 6 coins is the total number, so those 6 coins now, I want 6, I want the maximum I can get is 3, which is 0. Okay, that's fine. 7, this is 7. All right, 7, I want maximum. So basically, I take 1, 2, 3, 4, 5, 6, 7, and then, which is, hold on, 1, 2, 3, 4, 5, 6, 7. Yeah, I take this, and then I take this and this, right? So 1, 2 plus this, that gives us 9. But hold on, that ain't right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because it's 125. Yeah, that's 125. And then I think this is right? It's 351 plus 125, which gives 476. That's right. And then we go to this part. All right, this part is 8. Right? We want, wait, hold. As in our this? No. This is 1, 2, 3, 4, 5, 6, 7. There's 7 coins. 7 coins is temp I is 7 coins. So it's the current, whatever. So I do PS 7 plus that's 7 coins. Hold on, that's 7 coins. All right, that's 7 coins. So if I do 1 coin, just current, if I take 1, right, and then that's it. And then we compare. 2 coins, I can take 1, and I find this, or I can take 2. This is not right, right? So think about it. It should be for I in range K, right? I is the total number we are currently considering. And then for temp I, right, I can take for J in range, I don't know, K in range, len PS, right? Actually, we can just do enumerate, but it's fine. So for J in this, right? For J in this. So if I take 1J, right? If I take 1J, actually no, that's actually gonna be the minimum of I and len PS. Minimum I plus 1, right? That's how many J I can have. So let's say K. No, what? Let's do plus 1. Just I is the total number. It's not index. I is the total number. I is the total number that we are currently considering. Right? We're currently considering. Then why don't we just go back to K plus 1 if we do that, right? We just go back to K plus 1. Okay. So that's the total. So I is the total number we're considering. And for this I, we want to know if j, we do 1 to 2. Okay, so let's say it can be from 1, right, to lamb ps plus 1. Okay. So j is the total number we can take from the current ps, right? So now we say temp I, right, shall be equal to maximum, we don't know, maximum, it should be the current round. So it should be temp I, right? The current round. So it's temp I, and then what? And then I say I take PSJ. Well, I have to be J minus 1. That's the index. So PSJ minus 1, just take that many of J, right? And we need to take certain number of, so plus dp, right? So like we take we can go 0 times 0 will always be 0. So PS. So we take one of this. So we take one of this, and then we need to take. So J is a number, right? So we call it by I. So it's I minus J, right? I minus J. So I minus J. What's I minus J? I minus J is when we're currently looking for this number, right? So I minus J is the number, the actual number. So we go to dp, right? We go to dp, and that's the. So we go through the whole thing. And so J, we take 1, take 2, take 3, and then we go dpi, and then once this is done, now basically we're going through 2 rounds. Okay, so we go through 2 rounds. For each I, the current number we're considering, we have to go through J, all of them. Right? All of take 1, take 2, take 1, take 2, take 3, take 1, blah, blah, blah. Doesn't matter. And then once we're done, we say dp will equal to temp and continue. All right, try this one. God, this is awful. This is seriously awful. It's still not right. All right, it's kind of late, so yeah, we're gonna stop right here. I'll keep it, but again, I think we're on the right track. It's just, I feel like it's just some teeny tiny detail. If you look at this is not right. This is not supposed to be 115. It's supposed to be 125. Okay, it's supposed to be 125. How? Why would this be? Why would this be like that? I mean, for one thing, I think this should start with 1. Right? This should start with 1. Does it change anything? You know, it doesn't change anything. Doesn't matter. So, let's say this one's right. So this one, right? So I equals 1, right? So J goes from 1 to 2. So J equals 1, right? So temp will equals to maximum temp I 37 and currently is PS 0, we take 51, or DP I is 1, J is 1, DP 0, so that's 51. Okay, that's good. So that we're done with I equals 1. So I equals 2. Okay, so we tried I equals 2. So we can pick J is 1. So J can get 1 or 2. Okay, so if J is 1, then shall be 51, right? P is 0 plus DP1, which is 37. Yeah, should be 37. That gives 88. All right, 88. So currently it's 88. Which doesn't it's not bigger. Okay, now maybe it should be DP. $476. All right, so this one is no, so 351 is correct, right? And next is 8. We're talking about 8. So we say if we do one of this, and then we need to do 8 of this, and 8 of this, what we can get is 125. Right? So that's no good. Right, so if we do 2 of this, 115, and plus 125. Right? That's still not good. So all the way, we say we do 7 of this, and plus 1 of this. Yep, that's this. And then the last one will be 7 of this, and plus 125. That's 476. Okay, we get 476. Okay, that's fine. So now we go here. So the answer is, wait, what? How do we get to the answer? The answer is get 6 of this, and what? So 125 plus 44? Yeah. So it has to be 44, which means I take 44 and the previous 8, right, should be 325 plus 125. It should be a 450 at a 6th position. So 1, 2, 3, 4, 5, 6. So here, no, 8. 8. This position should be a 450. All right, which is actually here. So 3. Hold on. So that's here. This position, right? This position is wrong. This position is wrong because if we go one by one, right? We go one by one up to this spot. So that's 7. So now we want to do 8, right? We want to do 8. Should be 6 of this plus 2 of this. So we do go one by one, right? So let's say I is 8. Okay, I is 8. And then J, we go from 1 to 1 to 7, right? So we go one by one, right? One by one. And then it shall be maximum of dp maybe I need to copy it. And then I can just do temp. 450. Here, 450. Pass. We pass. We pass. So the key is I need to copy this because this maximum, this has to be the original DP. But I don't want to use the original DP because if I change the original DP, then we'll have problem. And I'm pretty sure I can do this going backwards, but I don't want to go backwards right now. So I'll just go forward and dpi minus j. So I have to, this one, add. Yeah, I cannot use dp because that means we keep going. We'll reuse, right? We'll reuse. So dp has to be something above because we'll use the previous one. But what if we go from back to front? Okay. Before we do that, right? Before we do that, and we don't need total coins, and we don't need this, right? And then we try these two. Pass. This is the thing. This is the thing. Oh. This is the thing. This one is right. Unless it times out. And then there's nothing I can do. If it does not time out, we shall be right. Oh, wow. Seriously? You time me out. Oh, it didn't time out. Oh, we solved this. Oh my God. All right. So, improvement. We have copy, which is expensive, right? We don't want copy. So now the ideal is we don't go from back to front. What do you mean by going from back to front? What I mean is, so we have a DP, right? So the new DP, if I keep updating from the right side, like we update this, because each one will requires the previous one, right? So we can update this. So let's say, I don't know, that should be from K, how about that? All the way to, we don't need to update 0. The 0 will all be the same, right? So this is from K. So now it's from K. And for J, we need to go 1, 2. So if it's 1, right? And then we do, that should be fine. Then let's say we don't need this, okay? Then we just go dp I equals dpi, yes, and then we don't do this. Oh, nice. So we are going from right to left to avoid a temp array. All right, so this is my final solution. 3 levels. We don't even need to do like that. Holy guacamole. For P in piles, okay? PS equals to list accumulate P. So let's save on this as well. It's still right. Okay. So this is the final solution. Again, run this one more time. Yeah, let's see. Shall be able to go fast because we don't have to copy. Copy takes a long time. Yep. Nice. Solved it. We solved it. Oh, wow. Wow. We solved it. feel happy, very happy. All right, so let's write something about it. So the key, I did take a look at, what did I look? It's not a hint. I didn't take a look at the hint. I took a look at the related topics, right? Related topics. And saw that my trajectory was correct, right? It is dp plus prefix sum. Okay, so the idea is we keep a dp list which records dp list where dpi, let's just do dp lowercase. All right, we say dpi is the maximum coins, maximum value, maximum money we can get, right, by taking I coins from the first pile to the current pile. I just realized that's a 2D DP, but we immediately start doing it in 1D, right? So we keep a DP list where DPI is the maximum money we can get by taking I number of coins, right? I number of coins from the first pile to it should be to the pile before the current pile, to the pile before, right before the current pile, right? Then we produce a prefix sum on the current pile. After that, we want to update dp. Thus, we go. Thus, we let I go from 1 to k. However, there is a trick here. In order to avoid using a temp array, we need I to go from k to 1. Anyway, for each I, right? For each I, we can compose this I by taking j number of coins from the current pile and I minus j number of coins from the previous pile, right? From the previous pile. And the max money we can earn by taking I number of coins is to compute the max value of, let's give a name, a prefix, right, PS. Right. To compute the max value of PSJ plus DPI minus J. Right, PSJ plus, well, PSJ minus 1. PSJ minus 1. Right, provided, yeah. Where J goes from 1 to 1 to minimum I plus 1, minimum I, and len PS. Yeah. So we keep updating, right, the DP array when each pile is considered. Right. Once all piles are considered, the answer is the max value in DP. What is the runtime? Oh, well, we have P, right? Let's call it N, O-N. And then we have OK, right? And then within each OK, we have the number, let's just call it M, okay? Where N equals len piles, K equals K, and M is the, I don't know, I say average length of each of one pile. Yeah, I think this one is solvable. Yeah, it's not too hard if you stumble upon it in the right direction. Top-down DP solution. Oh, MN. Oh yeah, AI. Yeah, that's why I said it's average. Right, average. Okay, so do we read their solution? I think it will be the same. It will be the same. Mine is bottom up. DP. Maybe we can write it. We can write something. Yeah, let's just write something. It's fun, right? How do we do? Oh, I think we write Python 3 here. One D DP, 1D bottom up DP. 8 lines. Well, I'm going to say Python, dynamic programming, 1D DP. The prefix sum on the current pile. I shouldn't say that. Let's make it more clear. In order to avoid, using an updated, using an updated DP value, we cannot use the DP value used must be from the previous round. That is not updated. Otherwise, we are double counting the current pile. Right? And then we say we need I to go from k to 1. And then we say for each I, we can compose this I by taking j number of coins, right, from the current pile and number of coins from the previous, from all the previous piles. The maximum you can earn is to compute the maximum value of this plus this, where j goes from 1 to minimum this, with each new pile. Okay. All right, once all piles are considered, the answer is the max value in dp. All right, so let's do this again. Oh, probably should include this one as well. Post. All right, that's it. That's it for today. Wow, I redeemed for previous 2 days poor performance. Very happy. All right, I'll see you guys tomorrow. Adios.